Now today in this lecture, we will discuss about switching network. So what is the switching? How we can use the switch network and why we use the switching network. So first we have multiple device. We have to problem how to connect them to make one-to-one and communication possible. So one solution is install a point-to-point connection between each pair of device, such as mesh topology and star topology. This is the solution, but this method impractical and wasteful because when we applied very large network, so other is multi-point connections such as bus topology are ruled out because distance between devices and total node of devices increases. So a better solution is switching. A switch network consists of series of interlinked nodes called switches. Switches are hardware or software devices capable of creating temporary connection between two and more devices linked to the switch but not each other. So switching technology are divided into three categories. First, circuit switch, and second is packet switch and message switch. So long distance transmission switch network like that, long distance transmission is typically done over the network of switch nodes. Nodes not concerned with the content of data, and end devices are station like computer, terminal, phone, etc. A collection of node and connection is a communication network, data routed by being switched from node to node. So simple switch network like that. Mainframe computers, personal computers that are connected with the help of switch nodes and 1 to 7 switch nodes shown in the figure. So in circuit switch, use the dedicated communication path between two stations, three-phase established in the circuit switch, establish, transfer, and disconnect. So must have switching capacity and channel capacity to establish the connection, must have intelligence to work out routing. And circuit switching application like that. Circuit switching used in the different inefficient channel capacity dedicated for duration of connection if no data capacity invested. Setup connection takes time. Once scanned, transparent and developed for voice traffic like that phone. This is the application of the main application of the voice develop the voice traffic like telephone. Now public circuit switch network are connected like that. Suppose telephone, end office, long distance office, and connected to digital PBX box. And this is the structure of the circuit switch network. Some telecommunication components are required for circuit switching like subscriber, device attached to the network, and second subscriber line like that local loop, subscriber loop, connection to network, few kilometers up to few tens of kilometers. And second component is exchange switching center and office support subscriber. And next is the component of the telecommunication like trunks, branches between exchange and multiplex. These are the telecommunication components. Now circuit establishment is like that. Suppose telephone number A, B, and C are connected with the help of end office, and these trunks are connected to intermediate exchange, and these intermediate exchange connected trunk with the help of end office of D, and each telephone are connected to each other. So circuit switch elements like that. Control unit. Here is the full duplex line to the attached devices, and digital switch are interconnected to each other like a network interface. So circuit switch concept like digital switch provide transparent signal path between devices and network interface. Control unit establish the connection generally on demand, handle and acknowledge requests, determine if destination is free, construct path. Now also maintain the connection and disconnect. So blocking and non-blocking concept are also used in switching. For blocking means a network is unable to connect the station because all paths are in use, and blocking network allow this and use the voice system short division calls. And non-blocking is permit all stations to connect in pair at once, used for some data connection. So blocking and non-blocking concept is also are used in the switching, and this type of switch is known as multi-stage switching. Space division switching is also is the example of the circuit switching. In space division switching developed for analog environment is separate from physical path, and crossbar switch is also is the space division switching example. Crossbar contain number of cross point to the square number on station, and lost cross point prevent the connection. Inefficient use the cross point. All station connected only a few cross point in use, non-blocking. So example of space division switching like crossbar, and these are cross point are connected to user and if input L lines and output M's line, the total number of cross require L into M. If M input and output, then total number of cross point required M into M. Next, circuit switching example of multi-stage switching. In multi-stage switching, reduce the number of cross point more than one path through the network, increase reliability, more complex control, and maybe blocking. Example here shows three-stage space division switching like that. 5 input and 2. The first stage are use the 5 cross 2 switch, 5 input and 2 output, and next second stage are used 2 cross 2 switches stage, 2 input and 2 output, and third last stage is 2 input and 5 output, so it's 2 into 5 switch box. So time division switching modern digital system relay to intelligent control of space and time division element are also used using the digital time division techniques to set up and maintain virtual circuit and partition low speed bit stream into the piece that share the higher speed stream. It is the time example of time division switching. And control signaling function like that audible communication with subscriber, transmission of dialed number, call cannot be completed induction, call indication, signal to ring phone, billing information, equipment and trunk status information, diagnostic information, and control of specialist equipment. These are the key point of the control signaling functions. And control signal sequence like both phone and hook, subscriber lift receive off hook, and office switch signal switch respond with dial tone, caller dial numbers. If target not busy, send ringer signal to target subscriber, feedback to caller, this a ringing tone, engage tone, unobtainable. Target accept call by lifting receiver. Switch terminates ringing signal and ringing tone. Switch established connection, connection release when source subscriber, etc. Common channel signaling like that. Control signals carried over path independent of voice channel. One control signal channel can carry signal for a number of subscriber channel. Common control channel for these subscriber line and associated mode like common channel closely tracked inter-switch and this associated mode like additional nodes, signal transfer point, and effectively two separate networks are used in common channel signal. Packet switching. Now next is switching, use the packet switching. Circuit switching designed for voice resource dedicated for the particular call. Much of time data connection is idle, data rate is fixed, so both must operate at the same rate. While basic operation data transmit a small packet, typically 100 octets, longer message is split into series of packets. In packet switching, longer message is split into series of packets. Each packet contains a portion of user data plus some control information. These control information main purposing using the routing and addressing information. Packet are received, stored, briefly buffered, and passed on the next node, store and forward. So example of packet switching like that application data control information packet are user are added in the packet. These packets are travel source to destination in form of packet and packet network uses the some control information like the routing and addressing. So advantage of packet switching line efficiencies, but because single node to node link can be shared by many packet over a time, so time is reduces. Packet queues transmitted as fast as possible. Data rate conversation, like each station connects to the and its own speeds. Node buffer data required to equalize rates. It is very important for the packet switching. Packets are accepted even when network is busy. Delivery may slow down. Priorities can be used. This is the advantage of packet switching. And switching techniques like that, station break long message into packets. Packets sent one at a time to network, and packet handled to two ways. Packet are handled in two ways in packet switching like datagram and virtual circuit. In datagram approach. In packet switching datagram approach, each packet treated as a independently means each packet follow its individual. Packet can take any practical route. Packet may arrive out of order. Packet may go missing. Up to receiver to reorder packet and recover from missing packets. So example of datagram like that. If a sender want to send the message, suppose message is 321 and is travel from the network. So packet are divided into individual packet form 321, and these 321 choose the different path independently to each other, and these packet are travel in the network and receive in the destination side. This is the example of datagram diagram. Now next, virtual circuit. Virtual circuit pre-planned route established before any packet set. The packet switching next category is virtual circuit. Virtual circuit is the example like that pre-planned route established the route between sender and receiver before the packet and data sends. Suppose that call request and call accept packet established connection like that handset. Each packet contains a virtual circuit identifier instead of the destination address. No routing decision required for each packet. Clear request to drop circuit, not a dedicated path. So virtual circuit diagram like that. If you sender want to send the information to receiver, so first sender and receiver are established the connection. After establishment of the connection, the packet are travel in form of stream. Establish the connection, and these packet is for travel source to destination in form of a stream and receive in the packet. This is the approach of virtual circuit approach datagram. It is different from datagram approach. Now virtual circuit versus datagram, if differentiate करें, तो virtual circuit like that network can provide sequence and error control. Packets are forwarded more quickly, no routing decision to make, but less reliable like that. Loss of the node loses all circuit through that nodes. Now in datagram approach, no call setup phase, better a few packets, more flexible routing can be used to avoid the congested part of the network. So some advantage of datagram approach and some advantage of virtual circuit approach. So it is the basic difference between them. Now next packet switching technique like message switching. Now message switching is also known as store forward switching because the switch is the descriptive term store and forward. It means a receiver message store and send a copy of message to other forward the copy of message to other nearest tower or nearest router. So store and forward considered a switching technique because this is the direct link between sender and receiver transmission. A message is delivered to the sender side path along the another its destination. Because suppose M messages want to send. So M messages are stored in the store and forward. It check the destination address. If not found, then send the message to nearest tower or nearest station, and then nearest station send the message to next nearest tower or destination point. So some basic difference between circuit switching, datagram packet, and virtual circuit like that. In a circuit switching, we require a dedicated path, while in datagram packet, no dedicated path are required, and in virtual circuit, no dedicated path are required. And second difference, circuit switching path established for entire conversation, while in data packet, route established for each packet, or while in virtual circuit approach, route established for the entire conversation. Okay. Now, third difference between circuit switching, datagram packet, and virtual circuit, like in circuit switching means call setup delay, because call setup delay are used in the circuit switching, while in packet transmission delay in datagram approach, and call setup delay, packet transmission delay in virtual circuit approach. Fourth difference, overload may block call setup, overload increase packet delay in datagram packets, and overload may block call setup and increase the packet delay in virtual circuit switching. No speed or code conversion in the circuit switching. In datagram, speed or code conversion are required, and virtual circuit speed and code conversion are required. Now next, in circuit switching, bandwidth are fixed, while dynamic packet, dynamic bandwidth, and virtual circuit switching is also used dynamic bandwidth. Now next difference, no overhead bits after call the setup in circuit switching. Overhead bits in each packet and overhead bit is required for the transmission. So it is basic difference, circuit switching and packet switching. Now in the next lecture,